Hello everyone. Am I clearly audible to all? And the screen should be visible anytime now. Yep. Is it visible to all? Quick +1 in the chat if things are working fine on your end. I'll just quickly check on my end if things are fine or not. Okay. Things are working fine. Chalo. So we'll talk about the weekly and bi-weekly contest that happened. So probably today a little longer session. I'll try to skip upon the easier problems because obviously we have two contests and it's at 10 o'clock. So I don't want to keep all of you waiting. ज़्यादा देर जगह के नहीं रखूंगा. We'll try to keep it short, crisp, and to the point. Obviously, I haven't read the problem, so it might take time because of that. In a sense that I just want to keep it natural in front of you that what we are kind of thinking of. But then we'll try to look at what exactly was there. But one thing, is there any way to raise doubt on contest question of yesterday? Yeah, you can raise doubt as in like on the AZ forum, you can do that. But then like one thing that I definitely feel that is a little demotivating is this, which is technically not possible, right? Which is technically not possible at this point. So probably people are using tools or like models which are fairly advanced and are able to get to the top ranks by parallelly like asking all the questions and then getting the answer and pasting it. Probably that is working for some people, but then there is nothing that that you can do for that, right? Because it's just tools, right? Yeah, they're just tools. The brain would never become that tool ever in life, so it's fine. We are just here to learn. Probably when there is so much of cheating, the only thing that makes sense is probably the stream where you can learn more than what you could have learned in the content, where you could have actually competed, no? So it's no longer a learning, it's no longer a competition. Think of it as if you are learning something. Now, before we start, I think somebody mentioned what is learning in live that you have learning in public. How many of you like follow me on LinkedIn by any chance? I think some of you do, right? Some of you do. So what I've made is a simple post today. Like I think I made it first time yesterday, which was around like building something in public. I was just trying to think of a product that I can make for all of you, all college students that they can use and they can essentially uh, try and make sure that we can make sure that something that we build is super helpful to all of you. It will be freely available to all, and we'll try to make it like a small product, right? But this is essentially the today's post, and I thought about it a lot. I was like in dilemma of three things, essentially doubt solving kind of thing, a little bit around DSA ladders and all, like some kind of trainer, online trainer sort of AI. And the third thing I was thinking about resume. But then when you think about it, DSA becomes a very small niche, right? And probably uh, I still feel that we all are using age old methods of resume making, which is no longer apt for the current industry standards. How many of you agree with me that we are still doing that overlift stuff where we are clicking on the text and changing the text by editing it on the latex so that we can get some latex resume, which is not even required in today's time, right? So this is something that I feel needs to change, and there has to be a product that makes it viable for everyone to make really good resumes to apply to tech roles or similar like techie roles, not Canva ones, right? So I think this would be one good project that we can take up. I mean, product, I will say. I'm not making a project. I'll not try to teach dev here. Maybe if I come across something really good, I'll teach on the posts. But then it's actually product building, right? Because I feel eventually we are moving towards people who will be just skilled to people who can deliver products, right? So this is something that I just want to keep as a like history of building something that I can refer to any student, that maybe even you can do something like this. If you are building something, just post a series of things that you are doing, that you are going through, and what is the like things that you might feel about things. This just took me I just spend 1 hour every day on this product, and let's see where it reaches. Sounds good to everyone? Like, let's see how this goes. Obviously, I'll keep posting it about a little bit on the Telegram too, exclusively, whatever I'm like building a little bit around designs and stuff. Some of, I think I had thought about this for a very long time, but I never just started about this product. And even in AZ, I thought about building it, but then I thought, okay, it's something that will take time. So maybe let's build this now, right? It's not built by community. It's a product. It's a closed product only for now, but then it will be freely available to all. It's just an example product on how to build something from scratch. It's not something I want you all to contribute on. There are tons of open source already projects that are there which requires contribution. Maybe not this one, but then maybe after this, maybe we can start with something that will be open source and we can all contribute to that. Does that seem like a good option? First, let's build one product and see. Collaboration, maybe I'll take 1 or 2 interns to help me with this one, but then I think I'll keep it non-open source at this point. It is nothing that is very fancy. Everything I'll do, I'll post it on the posts. Like, it will not be like a code that you cannot write. Every structured thought that I'll have, I'll write it down and I'll journal it. Okay. And probably I'll post everything. Okay. So it's not like something that is very new. It's just a product I want to build that you all can use. That's it. Clear, everyone? But in the process, I'll try to teach whatever I am learning, because today I was also learning about one more thing, that how others are building really good AI tools, right? I think, how many of you know about this agentic future that is coming up very soon? Agentic searches and architectures that are agentic in nature, right? Agentic AIs. So this is what probably a lot of things are building, a lot of people are building, and this is something that even maybe I'll try to use a little bit while building it. You all might think that it's like a lot of things are just sending a prompt to the AI GPT and then getting the response and showing it into the user. Probably really good systems need to do it much better than that, right? A lot of people feel that everything is a wrapper around API call of OpenAI, right? It's not that. There are a lot of other things that goes into picture around hard coding things, controlling the responses, re-rendering things, refetching things when things go wrong, using regex to correct mistakes of AI, things like that. Very simple things, having knowledge bases, a lot of things around those goes into picture. So probably I'll try to post whatever interesting things I learned. I was looking at few more things like DeepSeek and uh, like a search, like how do people build search around like architecture that people are using for search, agentic architectures that people are using for search. And there are a lot of interesting literatures I found, one by Glenn, one by some more papers I found. But then these are some things that I'm reading just to build this in a good way. I'll write about them, so keep following it, you will get to learn a lot, right? And photos, so don't photos, so you can ignore, it's just for LinkedIn. I don't want to do that, but then what to do? Create a course around your journey? No, I don't. I This is going to, whatever I'll build, it will be a free product, and I don't need another course, right? Is it premium is already there if you want to learn. I don't think world needs another course for this. Okay. Okay, cool. So let's with that start with today's discussion around Leetcode contest. How many questions were you able to solve in the bi-weekly, weekly? Just type down in the chat once. Gaurav sent you all the codes of weekly contest. Okay. I think I missed sending all the uh, like sessions. This 2 1 2 2 3 2. Okay. So is everybody fine if we take the last 2 problems of both the contests? Because I feel both are till 4 5 pointers. So if you read the editorials of the first 2 problems, it should be understandable. is it fine if we look at the last two problems of both the contest? Would everybody be okay with it? I know some of you might feel that Vivek second bhi discuss kar do, but I think if we discuss this, then this should become more easy only, right? And then for this also, if we discuss like harder problems, then this should be easy to understand given from the questions. Okay. Okay, so we'll skip first. We'll bruise through like second and then start with third. Okay, that's the funda. So we'll start from biweekly, and I haven't read the problem, so it might take some time because 8-pointer seems to be a little hard. But then we need second also. Okay, right. So I'll discuss the idea of this, but then we'll not go into too much of depth. Right, I'll just quickly breeze through them. One position seems cheating case. Yeah, a lot of positions seem cheating case to me, but then what to do? So you're given an integer array and BRR of array size n and k. You can perform the following operation on array inverter: split array into any number of continuous subarrays and rearrange these subarrays in any order. The operation has fixed cost of k. Choose any element of array and add separate a positive integer x. Cost of this is x. Return the minimum cost to make array equal to BRR and an integer k. Two continuous subarrays and rearrange these subarrays in any order. This operation has a fixed cost of k. Nice. So first of all, like whatever, so if you can split into any number, then you will break it into all pieces of one, and then you can rearrange it to whatever the order you need the other things into. And whichever elements are not matching, you need to add and subtract the closest number to it from the rest of the elements. Is that what the idea would be? I think something like that should make sense. Positive integer x to it. Choose any element and add in positive of this operation. X. Okay. So what are we looking into here? That there are like either you will use this operation or you will not use this operation, right? Either you will use this operation or you will not use this operation. If you use this, then I will rearrange the things that are matching perfectly, and the non-matching ones needs to be fixed by the second operation. But if I don't use this, all the elements needs to be fixed by this particular operation, right? Okay. So the second case is easy to check. You can just simply try to convert each element into the other. So that will give you the cost using only operation 2, right? Now the interesting part is if you use operation 1, then you get a fixed cost k. So you might as well like see what is common between the two and try to fix them as much as possible. And then the rest of the element you will sort and place it in a way that the minimum gap is there between the elements. So this is a very good question. I don't know if you like solved it understandingly or not. Basically the question is asking, there are okay, just a sec. I think I didn't enable the tablet once. Give me a quick sec. Yep. So basically the question is asking that you have the element values in ARR. Okay. If you use the first element, now you can rearrange anything anywhere. So you have to just correspondingly match things to BRR, right? So say, yeah. So when you have to make all of these elements go to these elements, it's always optimal to sort and bring the first element to the first element in BRR, second element to the second element in BRR, third element to third element in BRR, fourth element to fourth element in BRR. This is always optimal. Okay. This is something you can prove, because if you make something go here and something go here, you will pay the cost of moving things along this line twice. It's better to move this element here and this element here. It will be of lesser cost, because say if the length is a b c, the cost here will be a plus b plus c. Here a plus b plus c. Here it will be b. If you just do it here, it will be c plus this just a. So this is always better. So always sort and match them. That's the greedy strategy for such problems. Whenever you have two sets and you have to make them equal, and the cost is how much movement are you doing from one element to other, it's always better to match them in sorted order. That's the main idea for this problem. Is this clear to everyone? This was the main gist for this problem. Clear all? Quickly, +1. I'll wait for some +1s and then we'll move to the next problem. Okay. You are given an undirected tree. We'll move to what if numbers of splits are fixed? Then it's a very hard problem. Probably I might try to think of some sort of LRDP, that how much portion matches where. I might think it in that direction, but it's hard. Okay. So let's look at this problem. Seems already hard. And this is an 8-pointer. I don't know how much time it will take. I've not read it. So probably we'll do this at the end. आज रिव्यू तो नहीं हो पाएगा. Sorry if you are here for Leetcode review. We are trying to solve problems and already 2 contests and late night. So no review today. But then I hope you are here for learning. Okay. So you are given an undirected tree rooted at 0 with n nodes numbered from 0 to this. This is 2D array. Edges are there and there are lengths. You are also given an integer ems, number the value of node I. Okay. A special path is defined as the downward path from ancestor node to a descendant node such that all values of the nodes in that path is unique. Okay. Return the array results of size 2 where it is the length of the longest special path and is the minimum number of nodes in all possible longest path. Minimum number of nodes in all possible longest special path. Length of the longest special path. Okay. Okay. Yeah, we'll try to see. Third is harder than fourth. Okay. Okay, we'll try to dissect. This is a very good problem. There is something called as ancestral like structure. I'm trying to think that is what we will use, because we'll have to find the closest ancestor that blocks us. I think that might be the strategy. I'm trying to think. What is the length? Minimum number of nodes. Longest is the length of the special path where all the values are unique, and minimum number of nodes in all possible special path. Okay, so we are basically trying to find a pair where the length is maximum and the number of nodes is minimum. Do you agree that what we are trying to find is a downward path, right, such that the length, which is equal to sum of edges, is maximum, and then the second in this pair there is a second element which is number of node, which is minimum. So you have to basically maximize this and then minimize this. Does this make sense? That we are looking for a pair which has this as max as possible, and then among all of those longest path you have to figure out that one which has the minimum number of nodes in such path. Does this make sense to all? So whenever I think of such problems, right, it's a little complex that you have to return two things. And if you try to think of these problems like two problems, right, it will become very hard, right? So I'll try to think of it this, that I need to find a path whose length, comma, minus number of nodes is as max as possible. Find a path whose length, comma, this pair. If you think about this pair, length, comma, minus of the number of nodes is as max as possible, because it will try to first maximize length. For the ones that has the maximum length, it will try to minimize the number of nodes, because if you want to maximize minus thing, then it will minimize that value, right? Does this first idea make sense? This is the first level transformation that you have to think in mind, that when you have to deal with two values, try to build a pair that will do it. Clear, everyone? Is this first idea clear? So I'm trying to show you how to think clearly. Okay, coding बाद में करेंगे, ठीक है? पहले you have to think in a way that makes your coding and your life easy. Both situations are separate, so no need to think. Okay. Okay. Minimum number of nodes in all possible. Okay. Clear till this point? Two to five. 0, 1, 4. Okay. And then obviously the longest path is 2. Okay. So next thing, okay, how do I figure out? Remember my words very, very carefully. This is a path problem. Everybody agrees? In path problems, you have two types of problems. Only downward going path, or you might have path anywhere in the tree. Okay, some path like this. You need to count things like this. You need to count things like downwards. Only downwards. Only down or up, and in this case anyway. There are these type of paths, two types of path. Yes or no? Clear, everyone? In case of only down or up, you always try to see the answer from the downward nodes, the lowest node when it's a path problem, and the upward nodes when it's a subtree problem. Okay, whenever it's a subtree problem, you try to count things at the top of the path, like what if this is the top of the path, and whenever you have to find some path, you try to seek at the lowest node of the path, that if this is the lowest node of the path, what is the best length I can possibly do. Okay, whenever you have any path anyway, in such problems you try to count at the LCA of the path. For every node, you try to count, if this is the LCA, what is the best path I can make. This is a general strategy in all path problems of tree. This is a general strategy in all path problems of tree. Whenever you have to focus on only downwards or upward paths, you focus on the lowest node, like whatever is the optimal path, there will be a lowest point and the highest point, right? So if I find out in the tree, for every node, if it is the lowest node, what is the best path? If it is the lowest node, what is the best path? If it is the lowest node, what is the best path? If for every node I find out and take the maximum, will I get the answer? Because kahin na kahin to end karega best path jo bhi hoga. Yes or no? The best path will end somewhere. So if I find for every lowermost node, what is the thing? The second is, if it is related to, say, counting something in the subtree. This was a path problem. What if it was a subtree problem? Then you try to think of things in the subtree of every node. Something like InDP, if you have heard about it. So we will make it fast. We'll not obviously go through all the parents. We have to make it fast. But then, first of all, how do you count? पहले तो max निकाले कैसे, किससे निकाले max? पहले तो वो सोचना पड़ेगा. So path problems, try to find the best in the lowest node. For path problems where you can go anywhere, for every node, find the best path that crosses that node in two different subtrees. This is what you use in such problems. Okay, does this theory make sense to everyone? These are things that you practice and you learn. Okay, when you see 20 problems, then you realize that this is only how most problems are solved. यही सीखना होता है essentially. This is what you are supposed to learn while learning. हम लोग 20 प्रॉब्लम करके, पीपल से राइट प्रैक्टिस करो, प्रैक्टिस करके आप क्या सीखते हो? उस क्वेश्चन को सॉल्व करना कैसे? नहीं, अगर ट्री का पाथ प्रॉब्लम आया तो मुझे ऐसा सोचना है हर बार. दैट्स व्हाट यू लर्न व्हेन यू प्रैक्टिस. ठीक है, और यू कैन जस्ट ग्रैब दिस डायरेक्टली फ्रॉम हियर कि अब से अगली बार ऐसे ही सोचना है, खत्म बात. ओके, क्लियर एवरीवन? So basically our strategy would be something like, I'll go back to the question. that for every node figure out the longest path that ends here. इधर तो longest path end ही नहीं कर रहा है, 0 length. इधर longest path क्या end कर रहा है? This. So 2 length ending here, which contains 2 node. Now here what is the longest path? You can extend this till this node, but isko liya to it will become same value, same color. So you cannot take. So the length is 3 and then 2 nodes, right? So for every node we will calculate this same thing and then take the best. कि इस पे length कितना है, इस पे कितना node आया. For this node you will figure out what is the best you can do. You can take till this much. Length will be 6, comma. You can only take 2 nodes. For this node you will figure out the length is 4 plus 2, 6, but there are 3 nodes. Things like this. हाँ भाई यही पढ़ाते हैं AZ में. A to Z करे कुछ नहीं है, AZ है, algozenith. Okay. Okay. अभी उसको छोड़ो यार, अभी इस पे फोकस करो. So do you understand कि if I figure out the answer at every node, we can solve the problem. Does that make sense? कि अब इन दोनों में से मेरे को बस माइनस ऑफ दिस मैक्स निकालूंगा, it will be 6, -2. Perfect. How do you find this? Here is what I'll like use something called as ancestral property technique. Okay, I'll show you in one of my previous live stream only. I discussed this in the tree roadmap. I don't know if you saw that live stream or not. भाई तुम लोग अगर मेरे सारे लाइव स्ट्रीम ही देख लो बैठ के, तुम्हें इतने टेक्निक सीखने को मिल जाएंगे that you possibly don't even need any course. ठीक है, तो पहले उतना तो करो. I'll just show. I don't remember which Leetcode contest it was, but I was showing the roadmap for tree problems, and there was this technique that I mentioned there. I'll just show it very, very quickly. Yes, this live stream. Okay. So there was this live stream which I was taking. यहाँ पर मैंने बताया था there is something called as ancestral maintenance. ठीक है, ट्री का बेसिक आइडिया में आता है ancestral maintenance. Okay, probably if you have seen this stream, I think you might know, or I don't know if you know it about it or not. Okay. Okay, ये उसका ही टेक्निक है. Yeah, you can use prefix sums, I'll say, but I'll teach you a very general technique. Okay. Yeah, you can solve it with n number of methods, but I'll show you a very beautiful technique. ठीक है, very beautiful technique. कुछ नहीं. So whenever you are going through the DFS, you have a current ancestral chain, right? That when you go through DFS, what does happen? You go to 0, then 1, then 2, then 5, then retrack, then you put 3 here. So I'll do it this way. 0, 1, 2, 5, then you retrack, then you go to 3, then you go to 4, then you retrack, then you go to 4, and then you retrack, and then you retrack. This is what happens when you do DFS. है ना? So whenever you reach anything, any node, okay, you basically can maintain a data structure that maintains the ancestors in some way. So what we can do is we can maintain a vector which contains the ancestors. I'm just showing vector for now, and you can do any data structure for that matter. That I can maintain 0, then when I go to 1, I will push back 1. When I'll go to 2, I'll push back 2. When I go into 5, I'll push back 5. So whenever you are at a particular node, you know the ancestors that are there in this map, right? And okay, you know the ancestors that are there at this particular stack of the DFS. And then when you go back from the recursion, you can remove it from the stack also. So you can maintain the stack as you go. You can not just maintain stack, you can also maintain some other data structure like map of last seen color index. So red color you saw at 0 index. 1 you saw blue you saw at index 1. red you saw at, again, index, red you saw at index 2, okay, at this index 2. Then when you come to 5, 5 is a blue, so the last stop will be wherever you saw the blue last plus 1 index, till this much. This is the path that you cannot go above this 1, because this 1 is of the same color, because that unique property is now stopped. Does this make sense? So whatever this previous node can go till, and whatever is the new last occurrence of this particular color, you cannot go beyond those 2 points. Maximum of those 2 indexes is where you can go till. Does this make sense to all of you? So if I maintain what are the nodes that I've seen, okay, what are the nodes that I've seen, and the indexes at the colors last time we have seen this in the stack. So if you are going through this, some long chain, right? Some long chain. When you reach this node, you will try to find where have I seen that same value. Let's say this is 5, this is also 5. So last time I've seen this. So the best you can go till is this node. Okay. Now say this node could go till over here. So this is limited till this much. So the best you can do from here to here. Now from depth values, like in DFS, while doing DFS, you can maintain the depth from node 0. Say this distance was some 10. This distance was 20. So this gap will be nothing but 10. You can subtract the distance values. In the DFS, you can maintain something called as distance, that what is the distance from the root. As you go through the path, you can maintain the distance for every node. And बस अगर तुमको यहाँ से यहाँ चाहिए, तो this length is nothing but total minus this. So you can maintain distances while DFS. And the second thing you maintain is, where did you see this color last time in the ancestral chain? And while doing DFS, you revert what you have done, like when you go back. Can we do with prefix sums? Maybe, but it is way easier. I can do it with a single DFS, guys. I mean, if you think about it, this is a single DFS problem. Yeah, so for every node, you can check in the map, right, where you have seen previously, and its ancestor, where till which it can take. Minimum of those 2. Okay, this maximum depth of these 2 is what you will take. Clear, everyone? This is what is the idea for this particular problem. Yeah, ancestral property doesn't come very, very closely. A very similar motivating problem I can give you all. Okay, which I teach in the classes basically, that for every node, find in its ancestor the closest value to it and the farthest value to it. For every node, calculate in its ancestors the closest value, and the second is farthest value. Is it similar kind of problem? For every node in its ancestor, find the closest value, find the farthest value. How do you do that? For closest value, you maintain the set of all the distinct values you have seen, multi-set of all the values that you have seen till now, and using lower bound, upper bound, you can find the closest value. For farthest, you can maintain just max and minimum, and then from 2 extremes, one of them will be the farthest, right? So these are ideas that you can possibly come someday also. समझ में आया? This is what is called ancestral property maintenance, that you maintain some data structure for the ancestor nodes you have seen till now. And it can be anything. Clear all? ये idea समझ में आया? That you can maintain a data structure for the ancestors you have seen till now, और जब DFS में वापस जाओ, you revert it back. Okay? What I mean to say is, when you are doing DFS, integer node, integer like parent, integer distance. I'll not write the full code. I'll just give you the idea. है ना? Obviously, you all know how to write DFS. नहीं तो ये problem तो फिर अभी तो sense नहीं बनता, right? You can write DFS and all. So basically, what you do is, For like you generally write a for loop, auto v in neighbors of g, whatever neighbors of node and all. You write all these things, right? Before that, you add data structure dot add node, whatever property you want to maintain over here. And before you complete the DFS, data structure dot remove revert the last change. Okay, revert the last change. This is what you maintain in these cases. That you add this node, so you add that before going in this 2, you add red ka last scene 2 pair, and before after coming from loop, whatever was the previous value, you will revert it back to that. That is how you maintain it. So this is basically the code of maintaining an ancestral data structure. And this data structure can be global and it will be accessible for every node. You can calculate the answer here. Because this data structure will contain all the nodes that is there in the ancestor and not in the child, because you have closed it, so they have been removed from the data structure. Clear? This is the main idea. Now try to build on this, try to see how you can design this data structure. ये कर लिया तो फिर you will have this concept forever bore down into your mind. कभी नहीं भूलोगे. ठीक है? इसलिए sometimes I get a little lashback from students कि विवेक आप कोड करके नहीं दिखाते हो, आप पूरा रटवा नहीं देते क्वेश्चन, कोड करवा दो मेरा पूरा पूरा. अरे यार कोड जब खुद करते हैं ना समझ के, that is what builds immense amount of memory. Nobody can remember solution codes once they have seen it. Okay? But ideas that I couldn't solve for one day and I was able to think and finally code it, that I remember for my lifetime. That's how I have built my memory. Sometimes people say, Vivek, कोई तो question याद कैसे रहता है? Probably I've spent so much time on that problem. है ना? And obviously, if you're solving Leetcode hards, then the implementation should not be a big issue. Sometimes you need to learn implementation, but then it should not be that big of an issue. Clear, everyone? अच्छा लगा ये problem? Is this good idea for all of you? मजा आ रहा है? ऐसे आइडिया सीखने हैं भाई. Just watch all my Leetcode lives भाई. मैं खुद बता रहा हूँ. I'm not trying to brag or anything, but then उसमें बहुत अच्छे ideas covered. If you just watch all of them, you'll learn so much. Okay. Every stream probably you will get to learn something new idea. Okay, chalo. Let's move to the next problem. 8 pointer yaar, I think. Okay, let me read it once. You are given an n and m, n cross n contain nk identical pieces. Return the sum, return the sum of parent in every pair of pieces over all varied parents. Our placement of all k pieces on the grid with at most one piece per cell. Okay. Where the return the sum of parentheses in every pair. Acha. Okay. For all different things, you have to figure out the answer. Okay, identical pieces. Nice question, yeah. Contribution. Bas, I think this is a contribution. Can somebody confirm? Is this contribution technique? Okay. Okay. How many of you, like, I think a lot of people here are AZ students. In the last session, I was taking, like in the last week, I took a class on AZ on contribution technique. And I was discussing a lot of problems, which are absolutely important. I'll give one problem as a homework. Okay. the problems that we were solving was, one, find SOP, like SOS, which is nothing but sum of all subarrays of a problem, of a array, of a problem, of an array. Okay. Second, SOP, sum of all products of an array. Okay, which means you have to find sum of all subarrays of an array, sum of product of all subarray of an array. Okay, this is contribution one. This was I taught in weekday. भाई कोई मेरे क्लासेस के क्वेश्चन उठा के डाल दे रहा है क्या कॉन्टेस्ट में? हैं? क्या हो रहा है? लास्ट वीक कौन है भाई, कौन है जो मेरे टेक्निक्स उठा के लीड कोड वीकली पे डाल रहा है? हैं? ये कैसे हो रहा है? This is a contribution technique problem. This week only I took a class like last Wednesday, which was on contribution technique. These two problems I think was one of the major pointers. There are more ideas, but then this was majorly the two questions that you can try if you want to learn more about contribution technique. See, 15 जैन को ही हुआ था क्लास कंट्रीब्यूशन टेक्निक का. भाई किसी ने उठा के डाल दिया क्वेश्चन. क्या हो रहा है ये? ठीक है. Sum of all subarrays of an array. So for an array, go through every subarray and just find this. Then there is another problem called sum of product of every subarray. So if there is A, B, C as an array, find the sum of A plus B plus C plus A into B plus B into C plus A into B into C. Find the sum of every product of every subarray. These two questions you can try. These are very good contribution technique questions. Contribution technique has two forms. One is atomic item technique, atomic items contribution. And second is, there is, what do you call, extending ends contribution. Okay. In atomic contribution, there are more than, more ideas. Like for an array, find the sum of inversion of every subarray. There are questions like that which are possible, right? Where atomic item can be pairs. It's so that this question is of the form atomic item. अगर ये नहीं पढ़ा है तो possible नहीं है question कर पाना. If you haven't, भैया को split personality disorder है, उनकी एक personality AZ में पढ़ाती है, दूसरी personality उस topic का question lead code में डाल देती है. नहीं ऐसा कुछ नहीं है guys, ऐसा कुछ नहीं करता हूँ मैं. ठीक है, I don't even know who is setting these contest questions. ठीक है, but atomic item वाला technique ही है. This is almost that. Okay, so let's go back to the question. But this is a topic called contribution technique. है ना? So you are basically looking for contribution of every pair. This is contribution of every pair. Yeah, this is more maths. Okay, basically there is an n cross m grid for how many pairs, how many positions exist such that their Manhattan distance is equal to some x, right? You can try and loop on that and then try to see, like you can figure out how many positions are there whose distance is x. Yes, exactly. Right, Zazimus, you are correct. If you have solved that 2 nights problem in CACS, that's also something called as contribution technique. There is a very famous problem, 2 nights karke CACS pe. Correct. Thanks. Okay, so you have to figure out ki x distance wale kitne sare nodes hai, kitne sare ye hai. So for every cell, you can figure out how many x distance node exist. For every cell, you can figure out how many x distance node exist, right? And every pair will be counted twice, so you can half it. So for x distance, you have to find how many positions exist and how many ways are there to place the other k, and then you have to remove some double counting. So that you can possibly do. Okay. So it's a maths problem. बट कंट्रीब्यूशन टेक्निक पहले नहीं समझ में आया तो नहीं प्रॉब्लम है. हाउ मेनी ऑफ यू अंडरस्टूड दिस इज अ कंट्रीब्यूशन टेक्निक एंड देन वाज नॉट एबल टू सॉल्व इट? इसका एक बंदे ने ओ ऑफ वन सॉल्यूशन भी डाला था, दैट वाज वेरी गुड. ओके, ओ ऑफ वन. Yeah, I mean, we can try to think of the count as a formula, and then there will be an O of one formula only. Like once you know how many different ways are there to place 2 points with x distance, इसका अगर मुझे count पता है, count of x distance in the grid in an n cross m grid, count of x distance in an n cross m grid. If you can make a formula for this, then you can solve this in O of one, right? But I think ये closed form आ जाएगा कोई expression इसका, right? हाँ तो क्यों करना है भाई, ओ ऑफ एन कर लो. ओ ऑफ एन इंटू एम कर लो यार, इतना मेहनत नहीं करना मुझे, राइट? कर सकते हो ऑफ वन, बट क्वेश्चन वाज नॉट इंटेंटेड फॉर इट आई फील, बट कर सकते हो. आई थिंक वी कैन लुक इनटू दैट सॉल्यूशन. लाइक आई एम नॉट सेइंग दैट आई लव मैथ. ओके, या दिस इज व्हाट बेसिकली यू हैव टू डू लॉट ऑफ मैथ्स. केस वर्क करना है, केस वर्क करना है बेसिकली. सो ओ ऑफ वन पॉसिबल, ही इज ट्राइंग टू फिगर आउट द फॉर्मूला. राइट, आई लव मैथ वाला पोज देखो. सीम्स लाइक इंटरेस्टिंग यार. लास्ट में आते हैं, सिमेट्रिसिटी से कुछ कर दिया क्या इसमें? ठीक है, ये क्वेश्चन तुम लोग के लिए ऑफ वन के लिए नहीं बनाया है, बट इट्स अ गुड मैथ एक्सरसाइज. इफ यू वांट टू सॉल्व फॉर दिस, इट्स गुड. या इंडिपेंडेंट से करके लाइक ओ ऑफ एन टाइप्स करोगे तो दैट्स इजियर. या यू कैन थिंक ऑफ दिस आइडियाज. कंट्रीब्यूशन टेक्निक पहले तो हिट करना चाहिए एंड देन यू हैव टू थिंक ऑफ मैथ्स. ओके, लेट्स गो टू द नेक्स्ट कॉन्टेस्ट. एक बार कॉन्टेस्ट करके आते हैं, देन इफ यू लव मोर ऑफ मैथ्स देन वी कैन डेल्व इनटू इट. मैनहट्टन के ऊपर, हाउ मेनी ऑफ यू हैव सीन माय ओल्डेस्ट स्ट्रीम ऑन मैनहट्टन क्वेरीज, मैनहट्टन डिस्टेंसेस? देयर इज अ वेरी ओल्ड स्ट्रीम ऑन माय चैनल on Manhattan queries or Manhattan related problems. How many of you have seen this on, who is on here? Who have seen that video? Okay, even I believe that's one of the probably the best streams I have taken on this channel. Okay, that's probably one of the best streams I have taken on this channel. If you see that video, you will love every idea you see on that video. If you see that video, I can guarantee you will love every idea you see in that video. I think people who have seen that can testify to that, no? Yes, I'll show you once. If you go to my, I don't know, videos, oldest. No, this is Burnside is there. I taught Burnside very old. If you go to live and then go to oldest, yes, there is Manhattan sum queries. This is golden level videos. I'm very sorry I'm not able to make topic videos like this. Probably someday we'll start back with topic videos. But if I prepare a topic, probably you will start enjoying it again. Just go through these 4 videos, you'll understand. ठीक है. या जिसको पता है उसको पता है रोटेटिंग 45 वाला, वो तो बहुत ही खतरनाक आइडिया है. Okay, these are golden material. Chalo. Anyways, let's get back. Please make topic video. Yeah, we can. Thing is, life has become hard. I am already finding it hard to be able to make this lead code lives. यार और भी चीजें करनी होती है यार. I'm traveling. So by the way, if any of you are in Pune, probably I'll be in Pune from Wednesday to Friday. So if you are in Pune, I can meet. Okay, if you are interested. चलो, आजकल ट्रैवल में दुनिया चला जा रहा है भैया. हैव यू फेल्ट डिप्रेशन? ये कौन आ गया भाई? ये सब नहीं डिस्कस करना है मेरे को अभी. हो गया, हो गया. Only 3K people have solved more than one problem. Okay, the first problem though we'll skip. I don't think uh, there is any purpose. What about people in Bangalore? Yeah, Bangalore maybe I think it's very hard. I don't want to travel in Bangalore in general. But then yeah, I think I should keep a meetup sometime. Okay. I think you all should get added to the Telegram group. उस पे I'll update anytime I go. I'll put the thing for that. क्या बात है, मैं Saturday आ रहा हूँ पुणे को. First problem का higher scope. Okay, let's see if somebody has mentioned. So for a given integer nums for each index I, where this define a subarray start to I, where start is max of I minus nums. Return the total number of elements from sum defined for each index. Total sum of all elements from subarray defined from each index. Prefix sums. If you have to make it faster, then you can do prefix sum. Define subarray nums of चलो ये तो मेरे ख्याल से हो जाएगा जो भी है. O of n में prefix sum से तो हो जाएगा easily. You can even loop. Okay. Next problem. You are given an integer nums and positive integer k. Return the sum of all maximum and minimum element of all subsequence of num with at most k elements. Interesting question. 70 क्यों दे दिया भाई? ये क्या हो गया? ताकि लूप चला पाए. Again contribution technique है. Okay, there is a very good idea over here. ठीक है, to remove double counting. Okay, there is a very good idea using double counting to remove double counting in this. Pure O of n. यार k के लिए तो iterate करना ही पड़ेगा. I think O of n into k intended है. If k is there as a variable, how would I remove k? How would I remove k? I don't think that's possible. So let's assume with k only. पहले k से ही solve करते हैं, फिर solve करते हैं आगे. चलो देखते हैं, लिख के देखते हैं. So return the maximum and minimum. तो सिर्फ maximum निकालते हैं. If I just solve it for maximum, can I solve it for minimum also? It's the same problem, just reverse. हाँ, ये अच्छा problem. This is a hard problem. This is same problem as this. I'll show you. ये मैंने क्लास में पढ़ा रखा है. Super minimum sum. Let me show that problem. Find the minimum of every subarray of an array. Find the sum of minimum of every subarray of an array. That was the question. If you can solve that, I think you should be able to solve this question. Yeah, this question. I have solved this question in class. Find the sum of minimum of all subarrays of an array. Find the minimum of all subarrays of an array. Is this question similar to that? Yes or no? अच्छा, ये फोर्थ वाला क्वेश्चन है क्या? ओके ओके. हाँ, मतलब यहाँ सबसीक्वेंस है, वहां सब एरे है, बट आइडिया इज द सेम. अरे ये सबसीक्वेंस है, बट देन द आइडिया ऑफ फाइंडिंग दिस फॉर सबसीक्वेंस फॉर सब एरेज, लाइक द नेक्स्ट क्वेश्चन यहाँ पर जो है फॉर सब एरेज इज द सेम, नो? क्लियर एवरीवन? सो यू नीड टू नो दिस आइडिया. क्या है आइडिया? सीख लेते ही फटाफट, कुछ नहीं है, ज्यादा हार्ड नहीं है. ठीक है, इट्स अ कंट्रीब्यूशन टेक्निक क्वेश्चन ऑन द मैक्सिमम और द मिनिमम. ठीक है, ये सब आइडिया देखा हुआ होना चाहिए, तब फोर्थ प्रॉब्लम कॉन्टेस्ट में सॉल्व होता है. इफ यू डोंट नो कंट्रीब्यूशन इज सच आइडिया, तो ये सॉल्व कैसे होगा तुम्हें कॉन्टेस्ट में? ठीक है, कंट्रीब्यूशन तगड़ा प्रैक्टिस चाहिए इसके लिए. ओके, लेट्स लुक एट हाउ वी कैन पॉसिबली सॉल्व इट. सो आई नीड टू फाइंड that what is the, I can loop over every element and think that if this is the maximum, then how many subsequences exist such that this is the maximum? Okay, not just that, is it said that there are distinct elements? Yes or no? No. Okay, so we will figure out how many subsequences exist such that this is the first maximum. So इस side you can take less than equal to the same value, whatever value is over here. On this side you have to take less than x, because if there is a subsequence, okay, with this element being the minimum, then it will get counted over here also if that same value is present and they are both the maxes. अगर एक subsequence है जिसपे यहां पर भी x है, यहां पर भी x है, and they are max, so if you try to use contribution, you will contribute the x of this subsequence over here to the answer and over here to the answer, but एक ही बार contribution में आना चाहिए था. That is why when you use for max and min, you use for every element I to be the first max or first min. That's the trick of removing double counting in such questions. How many ways are there such that you can choose ith element to be the max, to be the first max of the subsequence you choose? Which means whatever elements you choose this side should be less than x, and whatever element you should choose from this side is less than equal to x. Right? Does this make sense to everyone? So now if you just want to figure out how many elements are there on this side which are less than x, that you can like maintain by some sort of like like while you are inserting, you can do some sort of counting. Yeah, we can sort the array. We can sort the array, but that will not count to the left, right? Yeah, it will work. It will work. It will work. Anyways, it will be on one of the sides, so it will work. How are you sorting it and solving the problem? Why will sort work? If you sort, say, let's suppose I can choose k elements. So this is one of the elements. So I have to choose k minus 1 elements. So let's suppose I will choose y elements from this side and k minus 1 minus y elements from this side. Right? That's the question. That at most k elements. Okay, at most k. Oh. Oh. Then it makes sense. Then for the this element to be max, I can choose any k minus 1 elements from the rest of the set. So when I sort it, okay, I get it. When I sort it, I can choose k minus 1 elements from the rest of the previous elements. Okay, I got it. It will be there in the like max wala case. So like in the min or max of the Subarray wala problem hai ye case aayega. Okay, this will come in the min and max of Subarray and not the other one. Subsequence it's easy because like you have this one on one side you can take equal. So anyways, you are just choosing k minus 1 elements from all the smaller elements. That's it. That's all you can need to choose. Okay. So subsequence mein, for every element, you just need to choose k minus 1 smaller element, and that many times that will be the max. Because it's like choosing a subsequence on any order does make no difference. So if the array was sorted, you still have to choose k elements. And in that, the last element will be the max always. Okay. So I choose k minus 1 times x, ARR of I. Summation of this I equal to 0 to n should be your answer, n minus 1. For ith element, if that is in the sorted order, for the previous smaller elements, you can choose k minus 1, and that set will have ARR of I as the maximum. Okay. Achha, there is given at most k. Okay, so loop over k equal to. Somebody is asking, is there a formula for n choose 1 plus n choose 2 plus n choose 3? Let's see. No, base common होता है तो कर सकते हैं. Power common, like ऊपर वाला common होता है तो नहीं कर सकते. There is something called as you can't solve that. There is no right formula. There is something called as hockey stick formula. कि Pascal's triangle में, if you sum something like this, its value is this number. Okay, this is called hockey stick formula. That if you n plus I choose k plus I, or n plus I choose k, something like this is the summation, then you can get a closed form for that. Okay, this is called hockey stick formula. And there is another formula in n-chooser called Vandermont's identity. Vandermont's identity, ठीक है. उसमें क्या होता है, Vandermonт आइडेंटिटी क्या बोलता है कि if you have to choose n choose I, m choose k minus I, ऐसा कुछ टर्म है. This will be nothing but n plus m choose k. Summation of this I equal to 0 to whatever min of n comma m is there. Voldemort identity. ठीक है, तो ये these are the two additional identities you need to know in combinatorics that sometimes pops up in competitive programming. इसके अलावा कुछ नहीं होता है. मतलब होता है, but I've never seen things being used in CP or DSA. Hockey stick formula is there, one which looks like this. If you add binomials here, it will be this. Okay, this value. So there is a formula for this. You can search this up. How to start CSCS? CSCS तो एक वेबसाइट है. CSCS पे क्वेश्चन से सॉल्व करो. That's it. अब इसमें स्टार्ट करने की क्या बताऊं? How do you remember formula? Because I know what does this mean. I know this picture, that's why I remember this formula. This is nothing but out of n plus m group, choose k. So out of n plus n boys and m girls, choose k people, k person team. It's same as choosing from n boys you are taking I, and from m boys you are taking k minus I. It's the same thing. That's why this identity holds true. I know the proof of this. That's why I remember formula like this. I know the combinatorial meanings of this. Okay, that's why I'm able to memorize all. Memorize to nahi. That's why I'm able to solve this. Okay, anyways, this is not needed. कहाँ चले गए हम? Contribution technique clear है. For every element, you are able to find how many times it will become the maximum of subsequence. Okay. Next पे move करें. So if we have solved this, let's solve the last problem also. Return the sum of maximum and minimum elements of all subarray of at most k elements. Same idea. Same contribution technique idea. There is nothing difference. भैया कब खत्म होगा? After you know its contribution, it looks easy, but जब तक क्वेश्चन नहीं पता तो कैसे easy है? I don't know. Is it easy? I don't think so. Code forces versus Leetcode. Where is learning better? I think the best learning happens on AdCoder. My personal belief. If you want to learn, go and practice on AdCoder. ABC का CDEF सॉल्व करना स्टार्ट कर दो. ये दोनों ही कुछ ज्यादा काम का नहीं है. Leetcode third fourth problem you will learn a lot. AdCoder is I think OG. And then CF. Okay. What is the other problem? Cost of painting eye with color J. They are colorful. Certified. No two additions of same color. All equations are not painted the same color. Finally, when equal says the whole equation is 0. How is equidistant from ends of the row are not painted same color? DP? Feels like DP. Okay. दोनों साइड का सीक्वेंस बना के बस मल्टीप्लाई करना है क्या सेंटर पे? कुछ ऐसा ही लग रहा है डीपी का. थ्री डी डीपी? अरे भाई 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 3D डीपी का तो डायमेंशन ही नहीं है. ओके. 3D डीपी भाई क्या क्या बता रहे हो तुम लोग? n इंटू 3 क्या है? अच्छा देयर आर जस्ट 3 कलर्स क्या? कैसा कैसा कोड करते हैं भाई ये लोग. ठीक है. हाँ ठीक है, मेक सेंस. 3 इज द नंबर ऑफ कलर्स. आई थिंक दैट मेक सेंस. कुछ नहीं करना है, 3D डीपी करना है इसमें. ठीक है सॉरी माय मिस्टेक. वो 3D डीपी का तो डायमेंशन ही नहीं दिख रहा है मुझे. तुम लोग कहाँ से कलर्स ही 3 है क्या? अरे सो यू बेसिकली whenever you have restrictions on both the ends तो दोनों को एक साथ fill करो, right? This idea kind of evolves from that problem called cherry pickup. I don't know if you know about this problem. How many of you have learned about this problem called cherry pickup करके एक problem है, right? So over there also there is this idea कि भाई दोनों same जगह पे एक साथ पहुंचेंगे. So maybe make them move together. Over here also we need to maintain the restrictions from both the sides, right? So generate both of this together and then try ki bhai you have to solve from I till n minus I equal to 1 to n minus I minus 1. This is the sequence. dp of I means how many ways are there to paint from I to n minus I such that on one end you have A, on the previous side you have A, on the last end you have B after this. Cherry pickup. There is a problem called cherry pickup. It's a famous Leetcode problem. Okay. dp of I comma ab says what is the, how many ways are there, what is the minimum cost, क्या पूछा है क्वेश्चन में, minimum cost, minimum cost, what is the minimum cost to paint I to n minus I, where the last color on this side has been painted A, this painted B. Three choices, and it's there in, there are different, like you'll have to iterate on the options here, right? Two options here, two options here. Clear, everyone? This is the idea. This is the DP transition that you have to think in this case. In AZ it is there? Yes, in AZ there is similar DP question, right? It's more like 2 pointers plus DP. Yeah, you can say that you are maintaining both the sides restriction. Okay. It start end color is ith and then end color should be I plus 1 mod 3. If start color is ith and then end color could be I plus 1. Yeah. The other two colors you can find by taking the next two colors. Yeah, that makes sense. It's a good idea. Today Jiangli reached tourist rank. Nice. Jiangli became tourist. I mean, ठीक है. He has ruled for enough time, no? Done his part. This is the DP. This is a direct DP problem. Where to practice so that I'm prepared for both way. Leetcode third and fourth problem if you are solving consistently on all contests. But adjacent cannot be equal. So here my choices are 1, 2, 3. Whichever is not equal to A, I can use that here. So I have my transitions, and over here I have 1, 2, 3. Whatever is not equal to B, I can use that here. So two choice here, two choice. Say I use C here and D here, so that C is not equal to A and D is not equal to B. I'll go to DP of I plus 1 C comma D. This is the transition I will go to. Clear? That is a transition. CD for loop, दो for loop होगा CD का, and then cost plus करके plus cost of ith index पे C and n minus I minus 1 index पे D. Okay. Okay. फटाफट लास्ट प्रॉब्लम रैप अप करते हैं भैया. कैन IIT वाले बाबा बीट टूरिस्ट एंड जियांगली? थोड़ा दूर है यार, IIT वाले बाबा तो अभी दूर है, ये लोग थोड़े दूसरे दुनिया में है. दुनिया अलग है थोड़ी भाई, ये तो ना हो पाएगा मेरे को लगता है, अभी हम दूर है. Okay, last problem. Maximum minimum of with at most key elements. So if I think about it again from contribution perspective, so if this is my maximum, then let's suppose this is X. You figure out the first element on the left side that is greater than X. That is greater than equal to X. Say over here you get Y, which is greater than it. So if a subarray starts before, say over here there is 3. Okay, you need to figure out how many subarrays are there whose maximum is 3. So agar yahan par 4 hai, if I take a subarray that is starting from before 4, will it ever give you this element as max? No, right? If I ever start before the previous element which is greater than equal to X, then it will not give me max as this 3, right? And on this side, I figure out the first element that is greater than X. Say over here there is a 5. So anything that starts somewhere over here and ends somewhere over here has this element as its max. ये exact same idea अभी दिखाया ना प्रॉब्लम में, सुपर मिनिमम सम, exact same ही तो क्वेश्चन है. देखो कोड दिखाता हूं, आई विल शो यू द कोड आइडिया. फाइंड द मिनिमम ऑफ ऑल सब एरे पॉसिबल ऑफ एरे. क्या करना पड़ेगा? On the previous side you find out what is the previous if you have to find that, if that is the minimum element, then there should be no smaller. So previous smaller, next smaller you calculate, and then for that element the contribution is you can start after the previous smaller and end before the next smaller, so that this becomes the first smaller element. That is the main idea over here. This is the contribution of this element into the answer. बस इस प्रॉब्लम में एक चेंज कर दिया है, एक ट्विस्ट एग्जैक्टली कि यू हैव टू हैव एट मोस्ट के एलिमेंट. तो कुछ नहीं इसमें से, बस इस विंडो में हाउ मेनी थिंग्स स्टार्ट हेयर एंड एंड हेयर एंड हैज लेंथ लेस देन इक्वल टू के. There are 3 lines here, then there is a 3, and then there are 4 lines here, 5 lines here. Find the number of arrays having length less than equal to 5. तो इसके लिए कितना ऑप्शन है? You can go till length 3, length 4, length 5, something like this. इसके लिए कितना ऑप्शन है? 1 2 3 4 5, राइट. इसके लिए कितना ऑप्शन है? टिल हेयर. इसके लिए कितना ऑप्शन है? टिल हेयर. So for every starting point you will get bunch of possible endpoints. उसको बस हमें sum up करना है और कुछ नहीं. So if say k is equal to less than equal to 5, right? So for every starting point you can figure out the farthest point till which it is valid. जैसे यहां तक valid है. Okay, and for this you figure out yahan tak valid hai, so you all these elements are possible. Okay, so you just have to find कि हर element के previous minimum, next minimum if you figure out, you have to find how many subarrays are there that start after this, end before this, and are of length less than equal to k. This will be a maths equation. Clear everyone? But it's absolutely direct modification of this problem that I'm showing you. अगर ये problem पता है तो I think if you have seen something similar, this kind of contribution, then it's very much possible to solve this problem. Okay. इसमें बस एक छोटा सा ट्रिक है, एक साइड पे यू टेक ग्रेटर देन इक्वल टू, एक साइड पे यू टेक ग्रेटर देन. Okay, that's the idea, so that you remove double counting. उससे क्या होता है, मैक्स तो मल्टीपल हो सकते हैं एरे में, बट इफ यू पिवट द मैक्स टू द फर्स्ट एलिमेंट तो वो फर्स्ट मैक्स होना चाहिए. दैट्स द ट्रिक ऑफ रिमूविंग डबल काउंटिंग. ओके, इफ यू आर इन एजेड तो ये क्वेश्चन एक बार पक्के से देख लेना. ड्रॉप इट. राइट, ये क्वेश्चन एक बार सॉल्व कर लेना एक बार प्रॉपर्ली. Okay, that's pretty much it. So a lot of contribution technique questions today, right? Contribution contest. Ancestral property was OP. Nice. भैया Leetcode profile review please नहीं यार, आज तो नहीं हो पाएगा. Is it में recorded videos रहती है? Yes, obviously. So basically you can go to these live sessions and कहाँ गया भाई 15 तारीख का क्लास मेरा, ये रहा contribution technique. So you can go and watch the video if you want. Right. So you can go and watch. Oh, I gave two homework problem for contribution technique and try this. Very simple question. I'll give this also homework for you all. If you want to practice more of this. नहीं यार अकाउंट बैन हो जाता है वंस AWS और कहाँ होस्ट करेंगे फ्रंट एंड तो वर्सल पे ही है AZ में कितना सिलेबस कवर हो गया इन द न्यू बैच आई थिंक आई हैड शोन द कैलेंडर राइट आई डोंट नो इफ यू नो अबाउट दिस बट आई थिंक आई शेयर इट विद ऑलमोस्ट एवरीवन क्या नाम है कैनवा पे आई हैड मेड दिस सो बेसिकली एवरी मंथ वी हैव अ सिंक मीट एंड उसमें हम लोग डिस्कस करते हैं कि अभी इस मंथ के क्लासेस क्या क्या होंगे सो आई वाज जस्ट लुकिंग आई विल शो यू ठीक है सो अभी तो हम लोग लाइक जैन मंथ में चल रहे हैं तो क्लासेस डेव की चल रही है ऑन डिमांड टॉपिक्स में मैंने पिछले बार फ्लो पढ़ाया नेक्स्ट क्लास इज ऑन मैक्स फ्लो ओके विच विल बी प्रॉब्ली ऑन वीकेंड्स बिकॉज आई एम आउट दिस वीक फिर अभी तो फेज 1 चल रहा है सो लाइक इस वीक अभी तो ड्रिल फेज दिस इज फॉर B8 क्लासेस उनका DP कंप्लीट हो रहा है अभी फॉर देम HTL हो गया प्रीफिक्स हो गया कंट्रीब्यूशन टेक्निक हो गया PNC वगैरह के प्रॉब्लम्स प्रैक्टिस किए अच्छे खासे अभी HTL के चल रहा है दिस इज वी आर ऑन द कैलेंडर से प्रॉपर कैलेंडर ही मेंटेन होता है एसेंशियली और एडवांस सेशंस अभी तो इसके चल रहे हैं क्या नाम है लास्ट वीक वी हैड ज्योमेट्री this week we had flow this week we will have max flow min cost MCMF and printing flows I think probably is what I will take up in the class and then next is ad hoc तो लोगों ने यही पोल किया है कि क्या क्या टॉपिक विवेक पढ़ना है तो विल डू दिस राइट okay I'll add the contribution technique to so for those who are in this I'll add it to the device का वो जो I think I had added it in the other course तो इसके device के phase 6 में मैं ऐड कर दूंगा ठीक है एडवांस CP वाले में I'll add over here all the advanced sessions plus the contribution technique clear so this is accessible to all batches ओके फ्लोज एक एडवांस टेक्निक है यार काम नहीं आता है इतना मिन कॉस्ट मैक्स फ्लो करके होता है फ्लो का मैं कोई एल्गोरिथम नहीं पढ़ाता हूँ यार हाउ टू सॉल्व क्वेश्चंस दैट्स व्हाट वी डिस्कस तुम्हें लगता है कि मेरे एल्गोरिथम पढ़ाई कोई फायदा होने वाला है मैं सब नहीं पढ़ाता भाई क्वेश्चन कैसे सॉल्व करते हैं वो सब पुश लेवल नहीं डिनिक्स ही पढ़ाया था मैंने बट आई डोंट गो डीप इनटू एल्गोरिथम मच contribution technique I'll get it added by tomorrow ठीक है ओल्ड बैचेस में B6 B8 मतलब जिनका भी अभी प्रीमियम एक्सेस है ऑल दोज पीपल आर डूइंग इट सो सम क्लासेस आर कॉमन except B9 के लिए it's not there next batch is from Feb end okay resume review when हम लोग सेपरेटली रेज्यूमे रिव्यू करेंगे यार आज ऑलरेडी इट्स नाइट आई डोंट थिंक आई विल सिट ऑन रेज्यूमे टुडे आज कोई रिव्यू नहीं लिखा हुआ है देखो यूट्यूब के मेरे टाइटल में भैया एजेड रेज्यूमे रिव्यू एंड बिल्डिंग कब ओके करते एक बार तुमने मेल किया था क्या जाजिमस ओके आई जस्ट चेक आई थिंक यू मेल्ड मी ऑन I'll get it checked today you mailed me to vivek@algozenet.com right मुझे तो नहीं आया यार. Build in public. See my LinkedIn. I think you'll get to know. Building AI resume builder. Yeah, I'm thinking about that. I'll do some feasibility review, yeah, because the thing is, whatever I'll build, I'll make it free. Okay. Any AI product free जब आप बोलते हो तो it has huge cost. So I just want to make that feasibility traded off properly. ये नहीं कि मैं बोल दूं कि बना दूंगा and then पता चला बहुत cost लग रहा है. तो I'll get that cost. Plus अच्छा प्रोडक्ट बनाए बिना कोई मजा नहीं है. देखो, एक है कि कुछ भी बना दे, ठीक है, एक और अच्छा प्रोडक्ट बनाए, है ना. अच्छा बनाने में थोड़ा मेहनत लगता है, कुछ भी बनाने में ज़्यादा टाइम लगता है. 1 out of 4 प्रॉब्लम सॉल्व हो रही है यार. तो फिर यू हैव टू इम्प्रूव ऑन योर डीएसए. बेसिक डीएसए भी अभी बहुत स्ट्रांग नहीं है, क्योंकि सेकंड प्रॉब्लम में बहुत हार्ड नहीं लगता है. सॉफ्टवेयर एज अ सर्विस नहीं, आई कुछ सर्विस नहीं है भाई, इट्स अ फ्री थिंग. आई बिल्ड इट एज अ फ्री प्रोडक्ट. ठीक है भैया. व्हेन विल एआई टेक ओवर ह्यूमंस? आई एम वेटिंग फॉर इट. इवन आई एम वेटिंग फॉर इट. चलो ठीक है. आई थिंक वी हैव डिस्कस्ड ऑलमोस्ट ऑल प्रॉब्लम्स फॉर टुडे. Not able to solve fourth problem. Solve all previous fourth problem that I've covered in my live streams. A lot of ideas get repeated. I can guarantee you that. So डीजे शीट के क्वेश्चन किए हुए हैं. कैन आई जॉइन योर? यस. मोस्ट पीपल हु जॉइन माय कोहोर्ट वही लोग होते हैं जो ऑलरेडी डीएसए शीट्स करके आए हैं, पर उसके बाद कॉन्टेस्ट के क्वेश्चन नहीं बन रहे हैं, क्योंकि 450 प्रॉब्लम रटना और एक्चुअल कॉन्टेस्ट में बैठ के नया क्वेश्चन सॉल्व कर पाने में बहुत फर्क है. ठीक है, तो उससे तो नहीं हो रहा है, ये तो मैं जान गया हूँ इंडिया में. क्योंकि तुमने वीडियो में सोल्यूशन कोड देख लिया है, फटफट जाके कोड कर दे रहे हो, उसमें वो नहीं होता है जो तुम सोच रहे हो, जो बिल्ड करना है एक्चुअली. ठीक है, तो मोस्ट ऑफ द पीपल हु आर जॉइनिंग कोड, आई नो दे हैव कंप्लीटेड. हाँ, रटना और नया से निकालने में बहुत फर्क होता है, वो सोचने में. मोस्ट ऑफ द पीपल हु जॉइन इज दैट्स द स्टेट एट विच दे जॉइन, कि मैंने पूरा डीएसए शीट कर लिया है, बट देन अभी भी मेरे से कॉन्टेस्ट में क्वेश्चन नहीं हो रहा है. I need to improve my problem solving skills. I will be very honest, I don't teach DSA much. DSA तो यार क्या theoretical वही है जो है ना. I mostly teach problem solving, कि यार सोचते कैसे हैं, ये आइडियाज एग्जिस्ट करते हैं, ये ऐसे सोचो, ये ऐसे करो. दैट्स व्हाट आई टीच. ठीक है, उसके अलावा और कुछ नहीं है मेरे ख्याल से विच आई कैन गिव एनीथिंग एक्स्ट्रा. मैं कोई नया एल्गोरिथम थोड़ी निकाल रहा हूँ. ओके यार, डीजे शीट को भी आई थिंक इट कैन बी टॉट इन अ बेटर वे, कि इंट्यूटिव वे, कि भाई कोड मत देखो, ये लो ऐसे, ये क्वेश्चन है पढ़ो, एंड देयर इज एन इंट्यूशन वीडियो वेयर यू बेसिकली थिंक अबाउट कि सोचे कैसे. दैट्स इट. कोड वोड तो तुम कर ही लोगे बाद में मर्जी के. ठीक है, बट देन वो सोचना ही हार्ड होता है एक्चुअली. Problem solving, I'll say solve a lot of aptitude question. It helps. I have seen that definitely. Second is stop looking at solution codes. वीडियोस भी देख रहे हो बैठ के तो सोल्यूशन कोड्स मत देखो. आई कैन गारंटी यू इट मेक्स ड्रास्टिक डिफरेंस. तुम सिंपल है. Every problem, if you have tried yourself 20 minutes before you see the solution idea and you have not seen the solution code, you improve. That's the simple formula. हाँ, डीएसए शीट्स आर गुड फॉर फ्रीक्वेंट इंटरव्यू क्वेश्चंस. डीएसए शीट्स आर जस्ट अ प्रॉक्सी फॉर फ्रीक्वेंट इंटरव्यू क्वेश्चन. जो इंडस्ट्री में जो लोग पहुंच गए हैं, उनको जो स्टैंडर्ड लीड कोड प्रॉब्लम्स पता है, वो वही पूछते हैं, तो इसलिए रिपीट होते हैं. तो इसलिए यू शुड नो दोस प्रॉब्लम्स. दैट्स व्हाट डीएसए शीट्स आर गुड फॉर. बट देन इट्स नॉट गुड फॉर ओए और कॉन्टेस्ट. कॉन्टेस्ट में तुम नया क्वेश्चन नहीं कर पाओगे. Jiangli crosses 4,000 rating. That is a very, like, I think I was expecting that somehow because हो रही था. भैया आजकल सब भैया दीदी ने अपने कंपनी को, या आई हैव नो कमेंट्स. आई हैव नो कमेंट्स. बट समटाइम्स आई ऑल्सो फील कि कुछ लोग जो पढ़ा रहे हैं उनका खुद का ही पहले इंटरव्यू क्लियर होगा नहीं दोबारा. मेरे को तो कभी उनका ही डाउट लगता है कभी कभी. ठीक है, there are a lot of good people also, but then some people I understand. vivek@algozanet.com पे मेल कर दो, अभी मेल करो, आई एम सीइंग इट. 16 वीक में भी तो पूरा नहीं हो रहा है, उससे भी ज्यादा लगता है. भैया बेक्ड रसगुल्ला खाया है? हाँ हाँ खाया है, खाया है. सैमसंग SWC प्रोफेशनल, आई एम नॉट 100% श्योर अबाउट दिस. आइडियल फ्लो ऑफ डीसी, यार कुछ फ्लो नहीं है यार. देयर हैज टू बी अ लेवल जहां पर तुम इम्प्लीमेंटेशन बिल्ड कर रहे हो. There are levels where you build your language ka acumen. There are levels where you build your problem solving skills. There are levels where you build visualization skills. इसके अलावा और कुछ नहीं है. Okay. लक्ष्य रिप्लाई करो फटाफट. भैया आपका चेस खेलने का अच्छा हुआ है क्या यार? चेस खेलने की वजह से पेशेंस इंप्रूव हुआ, आई विल से दैट. Is everything only knowing ideas to solve problems? 80% yes. 80% is you have to know ideas. 20% is bending those ideas to solve a new problem. At least till 21, 2200 level on code forces. Yeah. 1800 is a good mark, yes. How do you manage your time? कुछ नहीं यार, I manage a calendar. I manage a calendar, that's it. This is how I manage my calendar. अच्छा मेरा screen तो shared नहीं है. Oh shit, I cannot show the calendar. My mistake. There's something marked there. But then ठीक है. Anyways, there's a busy calendar that I have. उसमें work करता हूँ. Okay. आगे चले जाओ. लेवल 2 हो गया तो थोड़ा आगे चले जाओ, फिर बाद में आके वापस लेवल 3 कंप्लीट करना डीपी का. चलो यार, आई थिंक दैट विल बी ऑल फॉर टुडे. आई होप दैट विल बी गुड लर्निंग फॉर यू ऑल. भाई आपको दूसरे प्लेटफॉर्म से ऑफर मिलते हैं क्या? हाँ यार मिलते हैं. तो देन अभी तो नहीं करना कुछ. 14 फेब मार्क है, नहीं इतनी दूर का कुछ मार्क नहीं है. ए भाई अलग ही लोगों को अलग ही दूर दूर का चीज मार्किंग दिख रहा है. 14 फेब को तो मैं बाहर हूँ शायद. 14 या 15 फेब को आई विल बी इन सम अदर प्लेस. आई विल बी ट्रैवलिंग. देयर इज सम कॉलेज विजिट. हो नहीं नहीं भाई कुछ नहीं है. आई एम नॉट देयर. निराश करना पड़ेगा मुझे. I'm curious, could you share your lead code handle? Okay, okay, that will be among you guys. चलो ठीक है. कोई रेफरल है क्या बैकएंड का? यार बैकएंड का रेफरल तो नहीं है. इफ यू आर एक्सट्रीमली गुड, मतलब लाइक बहुत अच्छे हो अगर तुम डेव में, देन यू कैन रीच आउट टू मी. आई कैन ट्राई कनेक्टिंग यू. बट देन वो बहुत अच्छा का मार्क बहुत ज़्यादा ही अच्छा है. ठीक है. सोचो तुम अकेले अकेले लाइक कुछ एंड टू एंड प्रोडक्ट्स बना पा रहे हो एट दिस पॉइंट, तो फिर यू कैन रीच आउट टू मी. आई कैन कनेक्ट यू विद पीपल हु आर हायरिंग. बट देन स्टार्टअप्स में. बट देन ऐसे तो कुछ नहीं है. I'm trying to take your batch. You can call on the number that is there on the website, and I think the team will help you on that part. ठीक है. I can make end-to-end to-do app. वो तो AI भी बना देगा. उसमें क्या है? चलो then. That will be all from my side today. Thanks for joining in, everyone. We will meet in the next week where we discuss more questions, more ideas. Till then, keep enjoying and then keep having fun. Keep coding. Bye-bye. Have a good night. Yeah, you can call, actually. Bye-bye.